Hey everybody, this is Larry. This is day 18 of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, expression and operators. So still in Bilbao, I flew to Bilbao. I'm in Spain right now, so I'm just kind of doing these things hopefully as soon as possible so I could check out the city, whatever. I think I'm just resting today anyway because I've been walking too much the last few days and my knees hurt. Everything hurts a little bit. Everything's a little bit sore. So anyway, yeah. So let's get to this, which is expression and operators. Okay. Return order binary plus minus or star. Okay. Mm. When I see something like this, return all possibilities, I always think about, okay, let's look at constraints. The first one is that n is less than 10. That means that we can do something brute force and something like that. The second thing is that the two things I wanted to, okay, I was curious whether you could have multiple digits or you have to put an operation between every digit. That's okay. That means that it just becomes, an additional digit because now you can think about if you think about the number of digits and the spaces between them, and then 9 of them, I suppose, because for n is equal to 10, there are 9. And for each of those spaces, you could either have a plus, minus, star, or multiply, sorry, or nothing, right? And that means that there are 4 choices for each of the 9 spaces. So this is going to be 4 to the 9 algorithm. That's how I would think about it in terms of, right now I'm thinking about whether that's feasible. The other thing that I'm thinking about is whether the order of operation is thing. So this would be 10 of the, okay. So that means that star has precedence because 3 times 2 is 6 plus 2 would be 8. Okay. So these are good examples. I'm glad that they gave us a bunch. Yeah, and in terms of the target and whatever, we don't really have to worry about overflow with respect to Python, but in your other languages, you might consider it. Okay. I wanted the leading zeros as well. So I guess I could cheat a little bit, but this is more of a clarification more than a cheat, to be honest, if you ask me. But it's just me trying to figure out whether there is you do leading zeros, and the answer is there's no leading zeros. So okay, so we could do this, or just a better understanding of the problem, right? Because if there are 2 zeros, that's fine, but then yeah, it's not in the problem as much as I can tell, or it's not. They didn't tell you, right? So okay. Okay, so it does come to brute force, so we can kind of just go through it. Let's think about how we want to do it. In terms of implementation. So the algorithm, I think there's brute force, there's nothing to it. 4 to the 9th, 2 to the 18th, times 9, I guess. If we do another linear thing, so that should be okay. I'm just taking out a calculator. So 4 to the 9 times 9 is, yeah, or times 10 maybe, but 2 point something million, it should be okay, operations. A little bit messy maybe, but should still be okay. The order of operation thing is a little bit messy. I'm trying to think about how I want to implement that part. That part's a little bit weird. I guess we only care about the last digit if we yeah, I guess we only care about the last digit that we haven't used yet. So, or multiplication. So I think we can just do that. Because if you have something like 5 plus, I don't know, whatever, 1 plus 2 plus 3 plus 4, and then now times 5 times 6 times 7, when we're at the 5 and we want to do multiply, we just need to care about the 4, and we don't have to care about all the other stuff. In this case, this would be 20 as we do recursion, and here we only care about the last digit anyway. So okay, so I think we could do that as well. So let's get started. I mean, this is going to be brute force, but it may be a little bit messy. So we'll see. We'll go over something like, I'm just going to go because I don't want to think about it too much. Sorry, it's a bit confusing. But yeah, and now this lets us recurse on the index, the last number, and maybe the current total. And then current, if index is equal to n and current is, well, we have to return that one. If current is equal to target, then I guess we have to return. We have to keep track of the array or whatever. So yeah, then and an answer array. Then answer is append a copy of the array, and that should be good. If it doesn't, we just return anyway. I mean, in both cases we return, but that should be good. Okay, and then this is, of course, the easy part. And then the harder part is, yeah, okay. So the current is the current evaluation. Let me actually redefine these things a little bit. Maybe this isn't good enough though, because in the case of, like we said, 1 plus 2 plus 3 plus 4 plus 5 times 6 or something like that. Yeah, we have to keep track of this operation that's before. So okay, previous and prior op. This is getting a little bit messy, a little dicey. I don't know if this is the best way to do it, to be frank. You are watching me solve these live, especially in a foreign country, in Espanol, or in English, I guess. I'm not really speaking Spanish right now. So yeah, so this may not be, I mean, that's the thing, right, is that when you're exploring a problem, the first time you're going to do it, you might not get it perfectly, but, focus on getting it correctly, and then, think about the actual, think about how to get it to be cleaner and more readable as you go on. But that should be okay. Yeah. Actually, if we keep track of this in the array, I don't think we need it. But that makes this part a little bit more confusing. So yeah, we have to kind of finish passing prev. So here we go. We append previous, but then now current we add, or we current we do. So the last element in this case would be an operator, right? If there only be 2 cases, I hope. Then current equal to prev, else if oops. Wait, is that true? Oh yeah, it should be good. And then we add this to the array so that we can print it. This should be a string though. I'm returning an array. So so let's append the string, and then here we make it. So then we could just join this. So then now we don't need to. We could do it this way, I believe. So this got a little bit yuckier, but that's okay. And we also want to maybe just else assert false here so that it kind of crashes if it gets here, which it shouldn't happen unless, yeah, and that's if length of r is greater than 0. Because if it's equal to 0, then maybe we don't need to. But yeah, but in that case, current is just equal to prev. That means that if there's no previous thing, then your current string is just the current string, right? So your previous would be the current. So okay. Yeah, okay. I think we're okay here. We probably have to do some debugging later on. I have to check out the hotel in like an hour, so hopefully this is going to be done quick enough. We'll see. I was hoping that this would be a quick one, but this actually may be a tricky one. But yeah, so now we do try add. So what is the condition for adding? So index plus 1, because we parse it. Array, what do we do for the array? We Okay. I actually have to do some benchmark to see which is faster. So yeah, try add. What is the previous thing? So previous now. So that means that if we add, what does that mean? I think I have to do this thing here. I think I have to do this thing again. So yeah. But instead of current, we have next current. So next current. Next current is terrible, but nonetheless. Yeah, okay. So yeah, this processes the previous thing, and then now, yeah, the last element is array, and then now the new previous. What is the new previous? The new previous is the current. No, is that true? Basically, we want to have a delay thing. I just want to make sure our states are okay. Okay. So, oh, sorry, I messed this up anyway, but because of copy and pasting. So, okay, so next current, we add this to the thing. So basically, current contains all the results not including the previous, right? Okay, so then previous contains all the result before that. So this means that this is previous. Maybe the way that I want to do it is that, okay, so yeah, so this should be okay. So this should be current, because this includes the result not including the plus. I will have to try to debug this, to be honest. And the next current. Do we do this here? Does that make sense? Like, do we still need to do this? What is current again? Why am I doing current if I have the previous? Oh no. So current. Okay, I see what. All right. I think what I want to do is. So we want to update current to contain previous, and then now the next current is just current plus num sub in. I think I confused it a little bit. I still might be confusing a lot, to be honest. Yeah, okay, because they say this is the previous is now the current, which is updated with these things, and then here we update the current. I don't know if this is needed anymore in that case, because I think current just current contains the current, not including the previous. Oh, previous is just the previous number, not the entire previous sum. That's where I got a little bit confused. Okay, let me think about this again. So previous now would be num sub I. Yeah, num sub index. And then current, we have new current that contains the previous. And then we started a new previous. Okay, I think this is maybe hopefully okay. Sorry that this is confusing. This is confusing for me too. So yeah, let's try subtract. Subtract should be easier. I think this should be okay. Yeah, okay. I think for now let's start. Let's see if this works without. Let's see if this works without anything first. But yeah, I think one more thing that I want. I think I don't append a number enough, or like I have to append it here. So yeah, I have to append the previous first. Yeah, okay. And simply pop the other thing, so oops. Num's not in, isn't that in the, oh, no, num is a thing. Okay, fine. I need to do it anywhere else? Nope. I mean, yes, no, maybe. The previous, okay, because we converted them to strings. Maybe, I don't know, that's true. Okay, I mean, we have a prefix 0 that like I said, I might not have handled correctly, which is maybe okay. But it seems like we're on the right track. We don't have any of the, well, maybe not. The negative we're handling a little bit weird. But we're on the right path, I think. But there are obviously a lot of things wrong. Okay. Because of the, for example, the prefix 0. What do we, how do we want to do it? Yes. Oops. Sorry. Kicking things in the room. Okay. So we do not append. Uh, hmm, tricky thing is that we start to multiply and stuff like that. That might actually get messy. So, hmm, how do you handle the 0? That's the first thing in mind, and then the second is the negative stuff. Hmm, how did that happen though? I mean, the math is right at least. Maybe we'll see. Let's try another one. I don't know why I'm getting plus minus 0. That's a little bit of an odd one. That means that I'm, yeah, and I'm still, oh no, this one is just wrong. But really? Isn't it good? No, okay, fine. Oops. Yeah, I'm still getting this thing. The thing is that if we start to multiply, then I think that would mess us up. That's why I need to get rid of this instead of just like taking the substring or something like that. So, okay, you start 0, previous is 0, we append this if, okay, fine, if index is equal to 0 or greater than 0, yeah, because that means that there's no previous, maybe that'll be good enough. We'll see. We have to do another check for multiply. I think we'll be okay with that then. Yeah. Maybe we just need to handle. Maybe we just have to handle the first digits differently. I think maybe that's actually the real way to do it. So here we do num sub 0, and then we start at the 1 index. I think maybe that's actually a little bit better. And then the previous would be num sub 0, and I think we're okay. I think we need this to be. I think that we need this to. Yeah, I think that's why we messed up a little bit. Is that previous is supposed to be yeah, okay. That's why I was getting a little confused why we had to do this. Because previous should be an int. Maybe we should convert everything to an int. That's the input. What? Did I create something? 19? Nope, not this one. Yep. Okay. Don't know what happened here, but the previous number is 1. Okay, I think this should be okay, but now we're having way too much issues. Well, this is always going to be true now, so. Oh no. So now this is going to be the case where we do not have an operator. Okay, so this is actually greater than 1 because we're kicking off with 2. Okay, and then now try appending. Oh, now this thing doesn't. No, I think it's okay. Let's print every recursion real quick. So that's one thing I recommend is that break these things into parts, have kind of goes along the way so that you can debug these things, right? Instead of coding for an hour and then debugging. I think I did a backspace by accident. That's kind of terrible, but okay. It's okay. I only needed to test this case anyway. I mean, this is one case that I needed to do anyway. So okay, so the previous is 1. Oh, I think this thing is confusing, that's all. But I'm still missing a thingy. Okay. Why just isn't this? Oh, I think here I add stuff to the array and don't pop. Okay. Silly Larry, that's why. Because we're reusing the same memory. This one is on the end, so that one should be okay. Here, this is not. So we should only do this with returning to target, just for slight performance benefits. Let's do this join a little bit earlier. I'm still trying to get why I'm getting plus minus on the same line, like this one. I mean, this one looks good. Let's see. So 1, the current is 0, yep. 1 plus the last number. Prev, the current is still 0. Okay. I think I see what is happening here is that current is no, current should be 1 up to here. Once it picks 2, so the math is wrong. So it's this thing maybe. The length of array is greater than 1. Then we have this marker thing. But otherwise, I think this is an extra case where, okay, else current is equal to prev. Okay, so this looks good. Okay, let's see. Again, I'm focusing on plus and minuses only, so yeah, this looks, oh no. I was almost ready to be happy. I mean, this negative 0 was okay. I think we just, I wonder if I'm just not popping something correctly, because, let's see. This push, this pops, this push, this pops. We push this thing, but I think we do this and then we don't pop this one. So then one of the pops got rid of this one by accident. I think I'm just confusing myself a lot with how I do recursion. Usually I make copies of this and I think that's why. So yeah, okay, so that was it. I was just sloppy. So okay. So I think we're good here with the plus and minuses. Maybe. We'll see. But now we have to do we have to do two things, right? One is to get the order of operation correct. Well, I guess the other thing is before that even just get multiplication correct, which requires the order of operation. So let's do that. Okay, that's good because we don't have order. I don't know. That would be really turn out to be okay. Anyway, so then now I add this here so that I don't have to write pop every time, but then I forgot to pop it off in the beginning. I don't know, so that was a mistake. So try multiply. Let's see, what happens when we multiply? Well, now the previous number, we times that by, oh no, I forgot about one case, so maybe this is not good. I forgot about the case where, let's say you have 10 times 20. So then now instead of doing the 2, we have to, is that true? Yeah, I mean, because if we do like 10 times 25, you have to do this. You can't just like shift the digits. You have to do, oh no, this is a mess. What I did, I made an incorrect assumption, so this is going to be a mess, for example. So yeah, okay, well, like 250, I guess. Yeah, well, I mean, this code shouldn't run because I didn't finish typing something. Oh, wait, no, I didn't even type. Okay, no, I didn't finish typing something. So yeah, I don't know. If there's any, any smart way of doing this. I mean, yeah, okay. I mean, we just have to add one more thing, I think, but still. Let's actually let's define it. Here's the last number to be processed. Current is the running evaluation, and then we just need another. Yeah, I think we just need another current num maybe. The current number to be processed. Oh my. Oh my. Okay. Well, let's ignoring that for now. Yeah, so then here the new previous number as we said is uh, 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 um, only if it's multiplied. But this is such a hacky thing, so we'll see. But hacking it, and if it works, then that's fine for now, for the first go. But yeah, but I'm really not confident, to be honest. Well, maybe I'll do a more explicit none. And I could test for that later. Okay, try multiply. Okay. Yeah. Okay. So this just. I think I'm messed up anyway, to be honest. I think I needed to do that anyway because I think I don't handle this case very well before, so I think I was just wrong here. So let's actually backtrack a little bit and not do multiply yet and make sure we have this case. Once I have this case, I think we're okay. More okay anyway. So yeah, so then now, okay, then what is our thought process here then? I mean, we don't need this thing anymore, maybe. I mean, essentially, that's what we're doing anyway. I think I'm just being too. I don't know. I spent too much time trying to do this current thing. Let me just try to do it the dumb way. Yeah, because I think I was trying to like make so that this is faster. Let's just do the array and then we will. Yeah, this is got really complicated. I think the an important thing is just think you know just think keep it stupid simple and then we'll see. So let's return this for now. And then here we just go index plus one. So now we have add, which is just this plus, okay, that's slightly more efficient way. It's just, okay. We add the current number. Okay, we pop it. So that's add. Just going to see if I could get it right. Also, I need to time box myself a little bit, so I might finish this a little bit later. Because, well, I mean, I'm in the hotel. I'm going to get kicked out soon. I need to pack, so that's going to be tough. But yeah. And then here, the concatenation one is we take, okay. Okay, so then now we take the last element, and then now we add this to nums index, and then we pop. Now, and then we have to add back the previous number. Okay, I think this should be good, maybe. Yeah, I actually just had a dot where, what if I just did something like this? Would that work? I actually did not think about this until just now. We'll see if this works. We have to do leading zero stuff, but that's easy relative to other stuff. Okay. Oh. Yeah, okay. Leading zero, okay. Oh, they actually tell you not that you can do it. I didn't know that UL does that, but so this is just this part, which is the previous is not equal to 0. I think that should be good enough. Okay, I mean this looks okay. We obviously don't have to write sortedness or whatever, because we do plus minus first. We can actually do that just to kind of for testing, because I think it's better for testing anyway. Or like it's easier for me to test, though. I think this should be okay either way. This looks good either way, but yeah. Yeah, I was trying to be too clever, I think. Yeah, this looks good. Let me just give it a quick submit. Maybe that's what I should have done, but yeah. Maybe this is time limited. I should have adjusted it. Oh, cool. Yeah, I mean, I think so. The way that I would think about this, and to be honest, I'm cheating here. On an interview, this is no good. You can't do UL on a problem that's based on this, I think. But yeah. So I am traveling, and my time is getting tight. So yeah. But yeah, but just pretend that I did this, and you could implement this using a stack or something, so that should be good enough. All the other stuff is basically, this is just exhaustive, right? Um, you try multiplying, you try add, you try subtract, you try concatenation. What does that mean? And then at the very end, you have all these combination of things, and then you just calculate what it equals to. Yeah, like I said, this is going to be 4 to the 9 because there are 4 possible choices between every number. For example, if you have this number, and n can be up to 10, right? So yeah, if you write it out like this, for each space in between, it can be plus, minus, multiply, and concat, right? So that's 4 to the 9 because only 9 spaces for 10 characters. So yeah, 2 to the 18, but 4 to the 9 times 10, 10 being the join and the eval function. In terms of space, you can really do better than the output size. So yeah, and we didn't really do that much better than that. Anyway, this may be a dubious video because I kind of cheated at the end, but I gotta run. So anyway, stay good, stay healthy, to good mental health. I'll see you later. Bye bye.